What is the pH of a 0.1 molar solution of acetic acid? This is the score you're going to get, by the way, after you answer this question. So to find this out, we have to know the H plus concentration that will ultimately tell us the pH. And look at the Ka, or the acid dissociation constant that we're given. That's going to also help us. So Ka equals... So this is our H plus concentration that we want. This is our conjugate base, and this is our acid as a whole. So that's kind of going to look like, using the thing that we have, it's going to look like acetate ion, right? This is our conjugate base, and then at the bottom is going to be our acetic acid. But now we can just start plugging things in. So for Ka, we have this right here, right? So 1.8 times 10 to the negative 5. Now, we're going to call H plus concentration X. But the thing is, this is like the concentration of the H plus that dissociates from HA. So for every H plus that dissociates, we're going to get the same amount of A minus, because this is literally dissociating from this. So if this is X, this is also X. So we're going to have X squared at the top. And at the bottom, 0.1 molar is 0.1, and then we're subtracting from X, which is the amount of these that just dissociate, right? So now the thing is, right here, this bottom, this minus X is going to be very, very small. If you're subtracting from 0.1, it's not going to make a big difference from 0.1. So we can just ignore this right here, and that's just called like estimating. So what we ultimately have is X squared over 0.1 equals this. So now we bring this to the other side, and we're going to get X squared equals 1.8 times 10 to the negative 6. And now to find X, you just square root both of these, and you get X equals, here we have to estimate something times something equals something 1.8, right? Just do like 1.3, 1.4. This will equal like 1.69. If you did 1.4, that'll be 1.96. So it doesn't really matter. The main aspect is this part right here, which is times 10 to the negative 3, because this squared is going to equal 10 to the negative 6. That's our main aspect. And so now this is just our H plus concentration, which is what we want. And negative log of our H plus concentration is going to give us pH. So we can just sort of plug this in here at 1.3 times 10 to the negative 3. And now what do we do here? Kind of have to estimate, right? Because let me show you all some little trick right here. If you had negative log of just 10 to negative 3, this is going to equal straight up 3, right? But that's going to be like 1 times 10 to the negative 3, which equals this. What about if you had something closer to 10, like 9 times 10 to the negative 3 is very close to 10 times 10 to the negative 3, which equals 10 to the negative 2. If you did negative log of 10 to the negative 2, that's going to equal 2. So this is going to equal something between 2 and 3. What is it closer to? This is way closer to 1 times 10 to the negative 3, which is very close to 10 to the negative 3, right? So our answer is going to be closer to 3 than it is to 2, but it's not going to be 3. It's still going to be less than 3, because we're not at 10 to the negative 3. We're like at 1.3 times 10 to the negative 3, which is less than 3. As you can see, the range is from 2 to 3. So that means we can not do B, and then these are too high. So the answer, the best is